All right, let's look at reactions of nitriles. Gonna do an example of each one of these. Actually, number 1 and number 3 are actually the same thing, but we can never have enough practice. So the first thing that we're going to do is we're going to start with reaction 1. Reaction 1 takes a nitrile functional group and it converts it to a carboxylic acid. Okay, so we're going to start with an amide, a nitrile, excuse me. And one thing about just not using these generic R's, we get a chance to actually write out some actual reactions. So an example for number 1 would be triple bond N, and I'm going to put a OH on a wedge, a Cl on the wedge, hydrolysis, and do H2O or H plus or OH minus. Now, what this is going to give us, this first step is going to give us an amide. So we're going to go from a nitrile to an amide here. So for this reaction, the C triple bond N turns into C double bond O. Okay, so I have count your carbons. This is the best way to do it. 1, 2, 3, 4, 5. So I want to make 5 carbons. 2, 3, 4, 5. And bonded to that 5th carbon, I'm going to have a NH2. Okay, carbon number 1 here. It changes into a double bond O. Okay, so we have an amide, and we're going to keep the same substituents, OH. Don't forget to put those down. All right, and the next step, hydrating it again, we're going to take the amide and form a carboxylic acid. Okay, so H2O, and we're going to count our carbons again. This is 2, 3, 4, 5. That's going to be OH. So the transition from here to here, double bond O, wedge, OH, wedge, Cl. So the transition from here to here, from the nitrile to the amide, what happened here? Triple bond C became C double bond O. That N became an NH2. What happened from your amide to your carboxylic acid? Well, we kept the carbonyl carbon 1, 2, 3, 4, 5. But what happened was this NH2 transformed into the OH. Okay? So I want to get you in the habit of doing this as well, and you're going to do this for your assignment on this video. What is the name of this nitrile? Well, we have 1, 2, 3, 4. So we're going to have 3 chloro, 4 hydroxy, pentane, nitrile. That's the name of this right here. Okay? So, since you've already named carboxylic acids, since you've already named amides, I want you to provide the name the amide. So that's going to be number 1. Number 2, I want you to name the carboxylic acid. So once you're able to draw the structure and put the names into context, the reactions make a lot more sense. Okay, I'm going to do the second reaction where a carboxylic acid, this is reversed, it is turned into a nitrile. So second reaction, let's try this carboxylic acid. OH, bond O, Cl, and give you a hint, this is 3 chloro butyric acid. 1, 2, 3, 4. Okay, and we're going to put ammonia with it, and the ammonia is going to transform this into an amide. So we lose this OH and it becomes an NH2. Okay. Now, I'm going to name this amide for you. This is 1, 2, 3. This is 3 chloro butane amide. So as you're working these reactions and naming them, they should all come back to you. Okay? Now, from this amide, we can treat it with POCl3, and an amide with POCl3 is going to give us back the nitrile. Okay? Count the number of carbons that you have. 1, 2, 3, 4. Okay? So the C double bond O now becomes C triple bond N. So 1, this is 2, 3, this is going to be 4, it's going to be your N. So if I numbered this correctly, 1, 2, 3, 4, and cannot forget to put my Cl on it. So recall that we did what? We lost the C double bond O, we lost the carbonyl carbon. It became a C triple bond and a nitrogen. Okay, so we went from a carboxylic acid to what? An amide to what? A nitrile. How do we name this nitrile? 1, 2, 3, 3-chloro. And we have 4 carbons. It's going to be butane nitrile. Okay. So let's look at 3 is the same as 1, but for 3, number 3, I'm going to give you the reagent I'm going to give you this reagent. I'll give you this nitrile. And I want you to take it through the entire process like I did. So for this, take it all the way through. This is your nitrile that you're going to use for number 3. So here for about the stars, that's what you have to do. I want the product when you hydrate it. And then I want the product again when it undergoes hydration again here. I want that carboxylic acid product. So I want the structure and name. Okay, so for reaction 4, I'm going to keep the nitrile almost the same. So for 4, so for reaction 4, I want that to be a reduction. When you reduce this, I'm going to give you an example of 4. So this is 1, 2, 3, 4, 5. This is 1, 2, 3, 4. This is 4 chloro contain nitrile. Okay. So when you add lithium aluminum hydride to this, it reduces to a primary amine. So your C triple bond N becomes CH2. So I have 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So instead of this being straight, it's going to take the bend. 1, 2, 3, 4, 5. 1, 2, 3, 4. So I just have to put the bend down here. 1, 2, 3, 4, 5. So this is 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So I would have my melto group there. Where the C triple bond N was on 1, it is now a CH2. Okay. And now, where the CN was, it now becomes a NH2. So this is an amine. It is a primary amine at that. So when you get to number 4, I want you to take it all the way out. Lithium aluminum hydride. And the answer you will give me here is the name. So this is star number 6, name and structure. Over here, star number 7, name and structure. Okay. Now, number 5, I want you to number 5 and 6. So number 5, you can use the same reagent. Now I'm going to change your reagent so you can practice names. Okay, so I want you to name, try to go back in yellow, or some type of yellow with these. So this is star 8, name and structure. Okay. And the granular I'm going to add to this one is this. Because this requires a granular. If you look up here, that granular will lead to an imine salt, and when you protonate it, hydrate it, you will wind up with a ketone. So that here we're going to have name and structure. And then we're going to have H3O plus and name